Yeah.
I hope you all can hear me.
Yes.
Okay. Thank you. Thank you, sir. A very warm welcome to everyone present here in this forum of World Resource Webinar. I'm Priya, a talent management expert with a flair for technology, and yes, a work in progress currently in terms of technology, joining you all from Ireland for this session to facilitate this. Today, we are focusing on the topic robotics. We have some of the experts from the institutions and the industries to share their insights with us. So I request you all to make the best use of it. Few points to bear in mind before we start. Please be on mute during the session. There will be definitely a question and answer session time provided at the end, where the experts will be addressing your clarifications or any queries. And the participation certificate will be issued after the program and the workshop is complete only when the participant has both participation and the learning evaluation certificate. There will be a link provided at the end of the program. Those who have successfully completing this learning evaluation will receive the certificate. So moving on to the session, robotics. So today we are observing.
Yeah, can you put your video on?
My video is on, sir?
No, it's not visible.
Oh.
Now you are.
Okay, I'm sorry. I think the camera had, yeah. Okay, sir. So moving on to the topic of robotics. Today we are observing an augmented robotization in all areas of society, from manufacturing to assistive technology, from healthcare to education. These applications areas necessitate robots to be able to interact with humans in an efficient and socially acceptable manner. At the same time, like all technologies, robots may not only bring benefits, but also change how we think and behave. This calls for human-robot interaction. So the first speaker for our day is Dr. Var Lakshmi, who is an expert in this. Dr. Var Lakshmi, welcome, ma'am. She's an academician with 16 years of teaching experience and 8 years of experience as a researcher. She has completed her bachelor's and master's of technology in computer science and engineering. She's pursued her doctor of philosophy in medical image processing under Visvesvaraya Technological University in Belgaum, and has done a major contribution towards detection of malignant tumors at a very early stage. She has more than 25 journal publications and 5 patents to her credit. In fact, I'm keeping her introduction short, keeping in mind the time constraints we all have. Research Excellence Award, Excellent Paper Award, and Academic Excellence Award are few awards she has received for her work. Currently, she's working as an assistant professor in the Department of Computer Science and Engineering and heading the Cambrian House of Student Group, a Cambridge Institute of Technology, Bangalore, India. Being a passionate researcher, she's involved in several real-time project development in machine learning, artificial intelligence, and image processing. She's been invited as a guest speaker for several international webinars, workshops, and international events. Ma'am, I don't want to keep the audience waiting. Thank you so much. Please, over to you.
Thank you, Priya, ma'am. Thank you. So I'll just share the screen and the presentation. Hope it's visible.
Yes, ma'am.
Yes, ma'am.
Yes, yeah, thank you. Fine. Okay. So good afternoon, one and all. So today my topic is on human-centered robotics, and I thought of creating a basic introduction for human-centered robotics, wherein I wanted to concentrate more about the design factors which are basically used, like how people plan to design the so-called human-centered robotics. Because usually before getting into the actual phase of developing the human-centered robots, there are a lot of challenges what experts and as well several scientists they face when they go for designing this particular robotic planning, like how to go about with developing a robot. So I thought of concentrating more on the design factors. Okay, so before we start with, let me throw light upon the very information about what is basically a human-centered robot, why do we need human-centered robots, and where are they specifically used. So to start with, when we talk about human-centered design of robots, it's basically a science and the system wherein we are planning to develop robots in such a way they're able to interact as well as assist and almost work like human. So gone are the days wherein we're expecting robots to work along with human. Literally, we wanted robots to replace humans nowadays. So to that extent, we need to be perfect in our design. And why we need robots, why we need human-centered robots specifically. So there are several areas, okay, in the world wherein people work and it's too risky. It's like life-threatening situations of job for the people. So basically, we want to replace humans in such places with humanoids, right? The humanoid robots. So basically to save the human lives, and there are certain monotonous tasks which people can avoid doing it, or we can replace machineries, right? Or some robots instead of humans, so that the labor cost as well as a human time is saved over there. So in order to overcome that also, we concentrate on human-centered robots, and specifically to carry out certain tasks like when it comes to the dangerous task. For example, you need to identify who was got stuck inside a mine. So there are situations wherein we want to deploy a robot rather than literally instructing or expecting a human to carry out the task. So in this concern, I wish to highlight about the nanobots, wherein the nanobots will be able to carry out these tasks. It's like very small robots, almost in size of an insect, which can literally move into places to identify things which are literally unable to be discovered by humans. So to that extent, we have the applications over there. So where all we can find the human robots or the humanoids. So first and foremost, obviously in research and space exploration, it's quite common. And nowadays, humans expect a personal assistance. Starting from their very work, from the early morning work till the end, they need a personal assistant who is going to take care of all their work over there, and as well as assist them with respect to their jobs. Plus for caregiving, for be it a small kid at home or elders at home, we can assist them with a robot over there. Then for education and entertainment purposes, and search and rescue, what I mentioned just now. Thereafter for manufacturing, maintenance of stuffs, and basically in healthcare. So healthcare is one of the major domains which is literally gearing up with the applications or usage of robots over there. Yes, and as I told in the very beginning, what is that very important when it comes to the designing phase, especially with social robots? What is the thing we need to concentrate upon? So gone are the days wherein robots are in the lab. Gradually, they're moving into the real world. So what is more important over here is, rather than just concentrating on robot to carry out a specific task, we are trying to develop applications which will typically solve the human problem. Like any specific problem, we need to understand and identify first, of course, and understand the problem well, so that the applications will be able to solve the problem completely. So basically, we want the users to get a very valuable experience from the robots. It shouldn't be like the user has asked for something which basically all of us know. The requirement will be different, the end product is going to be different. So if it doesn't serve the purpose, it's going to be very difficult over there. And when it comes to designing for social robots, there are several challenges which experts are facing currently. So first and foremost, as I told, identifying the problem statement as such and scaling down from the problem statement to the specific use case, because again there will be several use cases which needs to be addressed to. So literally we need to identify which use case we are going to concentrate upon, and thereafter identifying the limitations. It's very important, because of course we cannot go for developing an ideal system. That's next to impossible. So when we are aware of what are the limitations and identify those limitations in the very beginning, it's going to minimize our error, so that we go for a robust humanoid development. And next one is going to be like setting the expectations for the user, have a clear-cut idea, and keep the users priorly informed so that their expectations are met. And next important thing is multiple methods of interaction, starting from the multilingual approach to the graphical user interfaces, what approach we are going to use for interaction of the robot with the human. So these are all the challenges which experts are literally facing in order to develop the human-centered robots. And next important thing is how designers are going to concentrate upon the cognitive model, how the computer vision is taken care over there. So it is not just we can't name it in a single term, just image processing or video streaming. It's like mix of so many things put together, be it machine learning, artificial intelligence, multiple domains put together. That's why we call it as a cognitive model. So how several factors are going to be taken care of so that we can go for even building new robots based on the need of the users. Yes. So when it comes to designing the robot, by default, the best approach which is being taken is always it is a user-first approach. So first and foremost, instead of trying to think like I'm going to develop a robot for this purpose, it's very important to identify what is expected from the user, what is actually the user need, what is the desire and intent with which they are expecting. For example, I want to develop an entertainment system. There, the requirements will be entirely different. On the other hand, if I want to develop a robot like a critical system to carry out a robotic surgery, so in that place, I cannot expect a robot to work in a different way. It should be completely error-free. So the user needs are very, very important over here. And next important thing is understanding the problem space where we are going to literally design and develop the robot. And last important point is once we have proposed a solution, we have identified the problem, scale down to the use case. Once we have proposed a solution, we need to check out whether that proposed solution is going to solve the problem. I would suggest even before going for developing the prototype, are we meeting the user's need? Confirm it, and then we need to go ahead with the design or the development part over here. So when it comes to design of social robots, there are basically three principles, almost like thumb rule, which people or experts generally use. So the three principles are actually human first, collaboration, and iteration. These are the three principles which people follow. So why human first? Very important thing, wherein here even the concept of this design thinking comes into picture. So when we apply design thinking, the first phase will always be like empathizing. We need to put ourselves into the shoes of the client or their needs, understand what they exactly need, have a clear-cut idea, and then go for developing. An extra important thing is the behavior of the client also needs to be considered over here. It is not just a need. You cannot visualize a client to be in this way. It's not like some imaginations or perceptions to be taken care over here. But we need to literally understand the behavior, how the robots needs to be deployed, and what is expected out of it. So both the need of the customer as well as the behavior need to be taken care. And very important thing is the several domains. What is the cross-platform domains we're going to consider? And the last important thing is the environmental conditions where we are going to deploy it and how the user is going to interact with the robot. Very important. And error-free hardware capabilities. And extra important thing is emotion. Again, the robot should be, in fact, and current R&D work, even in my own institution, we're carrying out this R&D work towards robotics. We are trying to develop a robot which is going to, identify the night vision situation in a particular hospital. Without the lights being switched off, we want to have a robot which is going to move across the various places just to take care of the safety and security of the patients over there. So it is like totally a trouble-free. A nurse need not go and switch on the light and then check over there. The robot is going to take care of it. So in that being the case, suppose a patient, the robot has to address to a patient. At midnight when the patient gets up, they can't get, afraid or get carried away by the robot's expression. So the emotion to some extent is also much important over the current R&D work we're planning, and we just get started over here now. So there are several factors which needs to be considered when we go ahead for the robot design. And next important thing is a collaboration. Of course, this also we have done over here. When it comes to the collaboration, see, when I mentioned just now, like our problem statement is almost fixed. We want a robot to move across the rooms and almost just monitor the patient scenario overnight. But it doesn't just stop over there. It's very important for me to involve several stakeholders, starting from the experts, the medical experts over there, the patients, at times, believe or not, even the patient's close relatives who are going to take care of the patients, the caretakers, everyone needs to be involved. So several people have to be pulled in order to analyze a problem in different perspectives. That's very important over here. And once we go ahead with a collaborative activity with the team, it's like wonderful ideas can be shared out. What we think about it will be very less. Different persons share their different ideas, so it will be easy for us to identify the problem appropriately and come out with the design process initial phase itself, so that of course the final aim is to be error free and with maximum accuracy. We want our problem to be solved and as well as the needs to be met, so we can take care of solving the problem in the design phase itself. Yes, an extremely important thing is iteration. So once we go for prototyping, we choose the prototyping approach. The third important principle is prototyping, because once a prototype is being developed, it's very easy to test the prototype and immediately handle the flaws over there. So all unexpected behavior, unexpected results, and a variant of the approaches, all this can be analyzed during the prototyping phase. So the third important principle is always iteration. We need to rework. Get back to the use cases if necessary. If needed, we have to again interact with the client, understand what it is, and again rework on the design process. So these three are the core principles when it comes to designing the social robot. And the next important topic I thought of brushing upon is the tools and approaches that can be used when it goes for the robotic design or human-centered robot design. So the first one is user needs and the problem space. Next one is value proposition design. And the last one is prototyping and testing. So when it comes to user needs and problem space, this is considered to be the very, very important step or the initial phase of any particular human-centered robot design. So the moment I go for the problem statement, I've understood the problem statement, my use cases are ready, I have freezed upon the use case, which use case I'm going to address to. Next important thing is choosing the framework. Which particular approach I'm going to use in order to identify the needs appropriately and define my problem space. So we have totally around 4 frameworks that are usually considered. One is the archetypes, next one is the proto personas, jobs to be done, and empathy mapping. These are the general frameworks which people use. So when it comes to archetypes, we have 2 types basically. One is the personas and behavior. When it comes to the users, like when I discuss with the user about what is their expectation, the personas is mainly focused on, like trying to identify the characteristic of the user. So in the same use case, if I continue, my mindset as trying to develop the robot over there will be concentrating only on the patient. My mindset will be going towards how far we can take care of the patient safety and security, how far I can monitor the patient over there, and without frightening the patient, very important. And any emergency, immediately have to raise an alarm over there. So this is something which is confining only to a specific, a specific stakeholder over there. But there is equally another part. There are like other particular stakeholders who should also be taken into consideration, and their characteristics also needs to be considered to certain extent. So this is something what we do in personas. Next one is behavioral. When it comes to behavioral, we try to describe the set of target behavior. Each stakeholder is going to be defined in a different way. When it comes to medical experts, their need is going to be different. They expect something different from the night humanoid robots over there, the robots which are going to be deployed. Similarly, the patients, similarly the caretakers or the hospitals at times. So goes on. And not only in hospital, at times even in places where we can try to replace the security also with such robots. So the group of people like whom we are targeting to, based on that, we go for identifying the needs. So needs and goals of a user versus demographic attribute that is specific. So we cannot just get carried away by the gender or how people are, from where are they coming up to. More than these things, what is more important is what is the need and goals of the user over there. More than considering about which type of user I'm addressing to, I need to concentrate more on the need of the users I need to address to. So these things will be taken care in archetypes. Next one comes like Proto Personas. Some designers, they try to concentrate or they prefer to use Proto Personas. It's almost like a standard template. They have some idea about the users. They would have developed something earlier. So with that prior knowledge, they try to use or retain the user data. So with that user data, they go for developing the design. So they don't interact directly with the client, or they don't try to interact with new set of clients specifically. So with whatever user data they have, with that assumption, they go forward. This is another approach. And the third approach or the third framework is the jobs to be done framework. So here, in the jobs to be done framework, we try to define, categorize, capture, and organize the job needs, which means a customer needs, which means I'm trying to get a clear-cut picture, the complete documentation, almost like our software engineering approach. So we try to collect all the requirement, get everything almost like signed. It's like approved by both the client end as well as the architect end. So literally we try to come out with statements in such a way, the statements are not going to be so dynamic. The user cannot take back their statement. They cannot tell, this is not something I wish to have. So it's like very professional way. We try to freeze it completely, literally freeze a requirement and then go for developing it. And of course, this is also applied in each and every phase. After designing also, we try to discuss, come out and get the consent and then go for the prototyping. So this is the jobs to be done framework, with some experts apply in the design. And last one is the empathy mapping. So when it comes to empathy mapping, as I mentioned just now, same like our design thinking. So literally the designer tries to put him or herself into the user's shoes. So they understand what is exactly the problem into, and what is a need, right? What is the user expecting? What is the final goal, or what our final human-centered robots has to do? So that is something totally decided, and then they go ahead. So these four are the basic frameworks which generally designers use. Yes, and the next one, when we try to visualize here, a very important thing when it comes to design is they try to develop something called as a value proposition canvas. So now we need to first identify the target. So once a target is identified, of course, we need to understand how the product or the experience is needed over there or is going to be used by the user. So once all this is taken up, all we go for coming out with value proposition statement. Literally, we try to describe the value, how that particular product is going to be used and how valuable the product is going to be for the user. If you ask me, this is something slightly different. When we tell like value proposition canvas, we also try to create a sort of like informally, if I have to tell, it is like trying to create a manual, literally trying to identify how this particular human-centered robot is going to be useful for the user. And the main purpose over here is to provide focus on the value. So we identify the problem, scale down to the use case, understood the need, but finally we are also freezing the value over here, typically focusing on the exact value, how to what extent that particular humanoid robot is going to be useful for the users. And if needed, we can also go for altering the solutions. If the approach is not going to be applicable, immediately the designers explore other solutions. Fine. So next important thing is the iterative testing. So when it comes to iterative design methods, we know we go for prototyping first, develop the prototype. And a very important thing over here is it is almost a very basic model. So just develop a prototype, test to some extent, you build it, and then immediately you go for changing it. If suppose the results is not as expected, immediately we can change it in the initial phase itself. And usually what the designers apply over here is the agile software development methodology, wherein there is a lot of flexibility in every phase. So in each and every phase, they can go for a change. So it's not like just freezing the requirement, jumping into design, freezing it, going into a prototyping. No, everywhere we provide the flexibility. So once a prototype is in hand, if you feel there is some problem over here, they completely redesign it. So most of the experts nowadays, they follow the agile development approach for designing the robots. And last one is, of course, what we discussed in now, the prototyping and the testing part. So when it comes to the prototyping and testing, many designers follow a slightly different approach. The major challenge what is being faced is nothing but trying to, pull in the people, means the end users, the users, as well as a robot, the developed robot in the same place, because geographically they can be in different location. So usually what the designers do is they try to pull in their own people. They try to make their own people as a robot. They just give a basic idea about what it will do. They don't have in-depth knowledge about the complete stuff, means the problem statement, use cases, nothing much. So that one of the team member itself will be playing the role of a robot and another participant will be interacting. So when an outsider, okay, almost a person who doesn't have any knowledge about what is going on technically over here, then he becomes or she becomes an end user. So that person, when they interact with this particular robot, they get to know, they understand very well. Means the developers, they understand very well. The designers, they get an idea, okay, this is where the flaw is, I can go for correct it. So all these approaches are quite applicable, and it's like basically used by several designers in order to design your human-centered robots. Yes, so this is something what I thought of sharing today. Thank you. So any questions, I'm willing to take it up.
Thank you, ma'am. Thank you for your insight on human interaction.
Thank you, ma'am.
Yeah. I request the participants to make use of the question and answer session. Dr. Var Lakshmi may not be able to join us for the complete session because she has tied up with few other schedules for the day. So,
or they can also feel free to share over mail also, ma'am. Anytime I can support them.
Sure.
Yeah.
Yeah, we will also, you can address it at later point of time if there's something to the email address.
You go to the next person.
Yes, okay. Ma'am, thank you for your time in between your busy schedules.
Thank you, ma'am. Thank you. Thanks for the opportunity, sir. Thank you.
Okay, so moving on next from Dr. Var Lakshmi, we move into an industry, automotive industry rather. So industry, especially automotive industries, are currently trying to become a benchmark for others. They are visualizing and converting their plants into a world-class manufacturing unit for their own organization needs. So let's hear from an expert in the field of automotive. We have Mr. Saravanan. Currently, he is associated as assistant professor in the Department of Automobile Engineering in Bannari Amman Institute of Technology at Sathyamangalam. Welcome, Mr. Saravanan. Prior to the current work experience, he was associated with numerous engineering colleges as professor, and his areas of interest are product design, automobile technology, problem-solving methodology. Mr. Saravanan, it's over to you, please. We are waiting to hear.
Thank you very much for the introduction. And first of all, I'd like to welcome you all for this webinar on robotics. Kindly excuse me for a while to share with you the screen. And, I think the screen is visible.
Yes. Yes, sir. You can make it a PPS show.
Yeah, just a moment, sir.
Correct.
Okay.
No, your video is not visible. Sorry, your PPT is not.
Yeah,
Now it's correct. Yeah, it's come.
Yes.
Visible now.
Yes, we can see it, sir.
Yeah, thank you. So I thank for this opportunity at an outset. My topic for the day for the webinar is the role of robotics in automotive industry. And I'm Saravanan. Just to start with, I would like to give a very short brief on what robotics is. So first, we all know the robot is an automatically controlled and reprogrammable multi-purpose manipulator programmable in 3 or more axes. So which can be either fixed in a place or mobile for use in industrial automation application. As the definition says that a robot is any system that can be used for any sort of purpose, especially where the human intervention is not required, which reduces the effort of human being and it eases the work to be done in a very simple manner. Yes. So to add a few more points to what Dr. Var Lakshmi was saying in her thing, we need to, I would like to add on few points on the history on how robotics evolved. So yes, it is often understood that the industrial robots have made their biggest mark in the automotive world, but it took actually many decades of refinement for them to get there. So here I have a small question, like how long has it been since robots got their start? We need to think and we arrive at some conclusion that it was long back. The most basic ideas of robotics originated in Leonardo's time, maybe. So the modern idea of robot made its first appearance in a play in the year around 1921, if I'm not wrong. So in this production, the robots were mechanical workers who helped humans, but they eventually revolted and they took over the world. To say this as an inauspicious beginning would be an understatement. So still, real-life technology soon began to catch up with the concepts. So the World War II actually represented a leap forward in technology. That is where the actual desire started and the actual demand started for the US automakers who had high quotas and constantly sought ways to improve the output. So the conflict accelerated the development of technologies like the first computer, even in such an even during that decade, and in 1970s, like when the first integrated circuit appeared, the automation race was on. So early industrial robots had no external sensors. However, they were still able to perform basic tasks like pick and place sort of thing. So this made automotive factories much safer for their employees, where they were meeting with many accidents, and that rate of accidents happening every year has reduced and has started to drop down year after year. So and you can see the first robot was officially named Unimate, and the prototype of the industrial robots were deployed in the General Motors facilities as early as in the year 1961. And after the Unimate, an improvised version of the robot was named Shaky. Then, as I just mentioned, the General Motors were the first automotive industry to implement robotics, after which Ford took over. So these first robots mainly performed the spot welding purposes. So their success soon attracted the attention from Ford, and in the year 1969, the Stanford Arm was developed with 6 degrees of freedom, which can perform as many tasks as a human hand can perform. So it was capable of tasks earlier robots couldn't perform. So in 1974, it was followed by a silver arm from Massachusetts Institute of Technology. So using the embedded pressure sensitive sensors and a microprocessor, this new arm was far more versatile. It opened the way for years-long robot boom with 30% year-on-year growth. So later in the 1980s, billions of dollars were spent by the companies worldwide to automate basic tasks in their assembly plants. Although automation system deployment did dip in the 1990s, innovative technology has caused it to rebound with a very rapid rate, especially in the automotive sectors. And the automotive automation today, the robots are an essential part of making automotive plants competitive. with interest in building plants through China, the stock of industrial robots in that country is expected to grow rapidly. It is not only with the country China, it is also now worldwide spreading, where many industries are getting into the field of robotics. They are making use of these robotics to get the job done and to meet the demand, which is keep on increasing day by day. And in recent years, even over half of industrial robot purchases in North America have been made by the automakers. So there is a lot many requirement in the field of robotics, which is to be implemented in the automotive sector. So, today's robots are far more sophisticated than their predecessors. So many more semi-autonomous with machine vision systems to interact within a changing environment is what we have to take a look on. So some can even work side by side with humans, which can be involved in synchronous tasks, and all signs suggest we are in the middle of new industrial robot boom. And now we can have a general classification of the robots. According to the main application possibilities, industrial robots can be divided into the manipulation robot, which is the most common type of robot designed to perform operations related to changing positions and orientation of objects, which are highly used in production machine tendings, palletizing, transporting of objects, and so on applications can be added to it. Then is the technological robot, which is designed to perform certain technological operations like painting, welding, where the depth of operation is a high concern. So for painting, you can understand the layer of coat is to be taken into consideration, which a technological robot can take care of. And regarding the welding, the temperature and the rate of the velocity with which the travel of weld must happen is also playing an important role in deciding the quality of the weld, which a technological robot can take care as well. And then comes the universal robot, which is an industrial robot that are able to perform several kinds of tasks like pick and place. So the end effector has to be replaced based on the requirement of the operation to be met out. And finally, we have special robots, which is designed to perform any one specific task. So now, nowadays, we can understand the automotive sectors has a separate unit for welding, separate unit for painting, where a specific robot is being used. And those are categorized as the special robots. And regarding the technological parts that can be used to define a robot are the sensors, especially. So the robotic sensors are, just to understand it, we need to know that I'm sorry, we need to know about the application of those sensors. Before the application of those sensors, let us have an insight on the need of robotics in automotive industry. So for more than 50 years, the automotive industry have been using the robots in their assembly lines for a variety of manufacturing process. Today, the automakers are exploring the use of robotics in even more processes. Robots are more efficient, accurate, flexible, and dependable on these production lines. So this technology has allowed the automotive industry to remain one of the most automated supply chains globally, and one of the largest users of robots. So with the thousands of wires and parts in every vehicle, it takes a complex manufacturing process to get components to where they need to be. It has to be identified. So the first one among the need of is the robotic vision. So a light industrial robot arm with eyes can do more precise works because it can see what it's doing, where a human eye needs certain protection, certain layer of obstacles, where a human might miss a chance regarding the process happening in an industry. So the robot wrist carries a laser and a camera array that gives the machine an instant feedback. Robots can now perform a proper offsetting when installing a part because they know where it goes. And the installation of door panels, windshields, fenders are more accurate with the robotic arms than the regular robot arms. And then comes this field of welding, where the automotive industry and the automotive makers are highly making use of spot and arc welding. So the large industrial robots with long arms and higher payload capabilities handle spot welding on heavy body panels. Smaller robots weld lighter parts such as mounts and brackets. And the robotic tungsten inert gas welding, we will call it as TIG, and the metal inert gas MIG welders can position the torch in the exact same orientation on every cycle. As we know that the automotive makers are the mass producers in the field, it has a requirement of performing a same task over many cycles. That is very important to maintain the quality of each and every part. And so preserving high welding standards in every fabrication is doable due to the repeatable arc and speed gap. So the collaborative robots on massive assembly lines, robotic welders and handlers must collaborate to keep the assembly line moving. And robot handlers need to place panels at the precise location so the welding robot can perform all the program welds. Once the above mentioned topics are done in the industry, then comes the assembly, which is the major part where the joining of many components to get a car as a shape or any vehicle. So in the process of assembling mechanical parts, there is a huge impact of using robotics. So in most automotive manufacturing plants, light robotic arms assemble smaller parts such as motors and pumps at high speeds where we cannot imagine even what a human cannot do. So other tasks such as screw driving, wheel mounting and windshield installation are all done by the robotic arm. And the finishing part in an automotive industry is giving an appeal to the vehicle. So the painting and sealing, especially once the painting and sealing is done, it has to be sealed as well. So an automotive painter's job is not that easy, and it's very toxic to boot as well. A human being cannot inhale such chemicals, and he cannot skip such a deed when he is into the job. So the labor shortages were also making it harder to find skilled professional painters. So the robotic arms can fill in the void because the job entails the consistency for each coat of paint. And robots can follow a programmed path consistently covering large areas, and it also limits the waste, which adds more cost profit to the industry. And machines are also useful in spraying adhesives and sealants and also the primers. Finally, once the job is done, it is used in the mobilization of the assembled part. So the transferring metal stamps, loading and unloading, pouring molten metal into the foundry, any sort of operation can be often dangerous for human workers without any PPE, or even like even a single mistake can end in a very hazardous accidents. So it may be lethal too. So there have been many accidents in this sector because of the above mentioned reasons. And this type of work is perfect for large industrial robots. Machine tending and loading and unloading tasks are also being done by smaller collaborative robots for smaller manufacturing operations. And it is also used in other operations like materials removal. Robots can follow a complex path multiple times without falling, making them a perfect tool for cutting and trimming jobs. Light robots with force sensing technology are better suited to this type of work. Tasks include trimming flash from plastic moldings, polishing molds, and cutting fabrics. They are also used in internal logistics, where autonomous mobile robots and other automated vehicles such as forklifts can be used in factory setting to move raw materials and other parts, especially from storage areas to the factory floor. And for example, in Spain, the Ford Motor Company recently adopted the autonomous mobile robots from mobile industrial robots to deliver industrial and welding materials to various robot stations on the factory floor, replacing a manual process, which has increased the efficiency of the factory production. And there are polishing robots where parts polishing are important process in vehicle production. So these processes include cleaning up automotive parts along the way by trimming metal or polishing molds for smooth finishes. Like many tasks in car manufacturing, the tasks are repetitive and sometimes dangerous, creating an ideal opportunity for robotic intervention. Material removal tasks include grinding, deburring, milling, some sort of other mechanical operations like sanding, routing, and drilling as well. And then comes machine tending, where I stated earlier, it is one of those tasks that are ideally suited for the cobots, which are also called as collaborative robot, which powers the automation. And finally, it plays a vital role in quality inspection that can make difference between successful production runs and expensive labor-intensive failures. So cobots or collaborative robots are used by the automotive industry to ensure product quality, which provides a wide variety of hardware and software, specially designed to help you automate your automotive quality inspection tasks, and including the cosmetic, optical inspection, and the metrology part of things to be done. So then comes the sensors used in the automotive industry, where I've been mentioning the first sensor to be discussed is the force and touch type of sensor, which are used by robotics to measure the forces. There are robots such as the robotic arm assembling mobile phones that we can see. It is important that the arm applies enough force to hold apart. When it is especially handling the windshield, it must not drop it down. So it must not get too many force, which can even break the windshield. So it has to decide on, it has to decide and maintain the force that has to be done. Then is the touch, which allows the robots to detect physical interaction between their body and the objects in the surroundings. So the capacitive touch sensors are used where the conductive properties to detect the touches, most commonly from a human's touch, but any object can conduct electricity that also will work. So resistive touch sensors do not use the electrical properties, but instead detect the touches based on the pressure applied to the plate. This type of sensors can allow a robot to navigate its surroundings, even if the object touching the sensor does not conduct electricity. It detects the environment. So detecting the environment, we have certain sensors that can use the measurements of environment around them to influence their behavior or just to collect data for analysis. Then is the temperature sensors that can be used in variety of contexts, not just as a data collection for scientific experiments. A rover on Mars can use its temperature sensor to evaluate the terrain for its rolling over. So it can play a vital role in the automotive sectors. Then comes the sensors that detect the light. So the detectable property of the environment. If a robot has a different task to accomplish at night than in a day, we can also assume a consideration for the robots that involve in welding, where a high intensity of light is applied, where it can miss out the job if it is replaced by a human being. So, so we have separate sensors to be involved in such operations. Then comes the sound, which has a similarity with the microphones, but are often attached to the circuits that compare the amplitude of the sound to a threshold value. It can act as a comparator, returning the results of that comparison to the robot. So the higher the amplitude, the louder the noise. This could be used by a robot designed to study wildlife, and it can also be used in the automotive industry or the automotive sector, where they test the horns. And it can also perform certain chemical testing. So robots can also use specialized sensors to detect the chemical properties, especially in the painting process of automotive industry, where the pH level of the chemical is to be maintained to avoid overcoating or undercoating of the material. Then is the object proximity, where the transport of any system is to be done without any lethal accidents that to be occur. So the mobile robots have to navigate the world around them, often autonomously, and there are sensors that help them detect the proximity of other objects around them. Then comes the infrared sensors, where they detect the changes in level of the infrared radiations that are caused when an object that is hotter than the background passes through the sensor's field of view. And the ultrasonic distance sensors are also used in automotive sectors, where a better sensor, it is considered to be a better sensor for robots that have to navigate around the inmate objects. And this type of sensors emit high frequency noises that rebound off the objects in the surrounding area and return to the robot. This is how the bats sense the world when they are flying at the night. And it is also being used by many areas, in not only in automotive sectors, but also in the other field where they use ultrasonic detection sensors. And now let us discuss on why robotics, why not the other technology, or why not the human being. The first and foremost advantage we consider is the manufacturing quality increase. So equipped with vision systems, automotive robots can detect variation in incoming materials and adapt their programmed paths to suit in a highly repeatable way. There we can see the less risks of obsolescence. So when products change, new parts are introduced, or processes change, the robot can be redeployed with a very little or even no additional cost. Just the programming has to be done for the certain task which is to be performed. And it also minimizes the workplace accidents, which cuts accidents and injury claims by removing the workers from dangerous tasks and environment. And the robots don't suffer from fatigue. It hardly requires rest, especially with proper maintenance. So cycle times are constant all days and every day, and the peak production rates are consistent. With all these, we can have a future outlook on the implementation of robotics along with the artificial intelligence. The system will become the norm in automotive manufacturing over the next decade, and the machine learning is set to improve every area of production and the manufacturing operations as well. So over the next few years, it is certain that robotics will be used in working toward created autonomous vehicles already, or the self-driving vehicles which is being used by the Google to have a survey on the maps. The 3D mapping and road traffic data will be essential in creating the automotive manufacturers to innovate their products, their production lines. They will also have to be innovated. And the automated guided vehicles will be playing a vital role. And these robots we can see has long been used in automotive manufacturing and is in common place in every plant below or these are certain areas where the future of robotics is into. The self-driving vehicles, which the Tesla has already launched. We know that they are playing a vital role in the automotive industry alongside the electrical transition which the automotive sectors are into. Then the 3D printing of the parts, more strengthened parts can be manufactured at a rapid rate, even in the advancements by including the robotic technology in the 3D printing of any parts. And the advancements of AGVs, like the automated guided vehicles, are used to haul heavy objects and materials around large manufacturing sites. Using pre-programmed softwares, these forklift-sized vehicles do not require a driver, and they use 3D map technology to navigate their way around the industrial buildings to mobilize any parts. And then comes the welding robots along the AI systems. We have other applications like painting robots. With the help of AI system, we can automate the painting process. We can decide on what has to be done with the selection of paints, with the process like pre-coating and post-coating of the paint. Everything can be handled with the aid of artificial intelligence alongside the robotic technologies that are being used in automotive industry nowadays. So with this brief insight, we have a lot more to know about the robotics role in automotive sector. This is just a beginning, I would say. And if you have any doubts, I'm open to those queries.
Thank you, Mr. Saravanan. Definitely, it's not brief. It was in detail, your presentation. Thank you for that.
Thank you very much.
Participants, if you have any questions to be addressed, you could make use of this time, please. If not, we can move ahead. Yeah, we'll just keep. Okay, so I think we can move ahead.
Yeah.
But if there is any queries still, you can please type it over the chat still.
Yeah.
Thank you, Mr. Saravanan. Thanks again.
Yeah, thank you.
Okay, so yeah, moving on to the next part of the session today, we have Mr. Sriram. He's an expert from the industry who's involved in manufacturing of robots. Yes, Mr. Sriram Nagarajan is the CEO of RoboRAM Technologies. He holds a degree in robotics and automation. He has specialized in multidisciplinary project management in the field of integrated automation, microcontroller testing and application development, low-cost automation, and RPA application developer. So artificial intelligence and robotics aid to enrich employment as the main goal with emerging technologies. It is not definitely to replace humans in their jobs, but make all process safer and more efficient. It is not a confrontation, but rather a beneficial collaboration between automated robotics and humans. So we have Mr. Sriram here. Mr. Sriram, over to you, please.
Yes, ma'am. Thanks a lot for the nice introduction.
You're most welcome.
Yes, ma'am.
Yeah.
So this is Sriram Nagarajan, CEO and co-founder of RoboRAM Technologies. So I'd like to express my sincere gratitude, first of all, to the World Resource Webinar for providing this opportunity. So yes, we are from RoboRAM Technologies, a business that focuses in industrial automation, robotics, PLC automation, IoT solutions, and RPA services are some of our primary services. And we have been in business for the last 4 years and have a long way to go. And since today's topic is about totally on AI and industrial automation, I would like to discuss how automation may assist industries and as well as the various case studies. Instead of making the session as more theory oriented, so I like to showcase few case studies. I just would like to present during this session. So I'm hoping this session, maybe the next 30 minutes, will be like a research documentary film based on my perspective. And I will begin my presentation from here. And I want to thank you all again for joining to this session, especially after the light of the difficult situation that we are all faced in the past. Hope it will be a great upcoming years for all of us. So today's topic is role of AI in Industry 4.0. So before, I just want to give a glimpse about what are the different technologies as previously explained by two explained all the major technologies covered under industrial automation. So industrial automation is the biggest one today. So every industry is now adapting the automation technologies for various reasons. I would like to show one video with you, so to know about what exactly the industrial automation is. So industrial automation is the process carried out by the manufacturing, especially the manufacturing industries with a little human involvement. So industrial automation allows these processes to be happen in a more optimized way. Optimized way means like they will need a higher production rate at a very shorter period of time. So manufacturers normally uses machine that operates through different controllers like PLC controllers, logical controllers, HMI, and even with robotics. And automation uses logic and programming to feed the machine information and carry out the process. This is what general thing. And we can segregate the automation into two types. One is a hard automation, and which is also called a fixed automation, used for batch production and for repetitive size and shape. Next one is the soft automation. Soft automation or a programmable automation provides flexibility and it will give different products. So the major advantage of using industrial automation, you may get this like high reliability first of all, and increased productivity, high quality assurance, and from this you can easily get the you can easily reduce the labor expenses. So let's see various automation technologies one by one. Most common automation, first of all, is the ASRS, is the automated storage and retrieval system. Maybe you can see this technology in the particular frame. So it is actually the fast material retrieval system. These machines are customized for the environment and the facility they have. So you can see this machine is actually used in the Amazon warehouse, used to store and retrieve the material at faster rate. And another one is the 3D printing technology that allows the users to create 3D models and manufacture without any waste. That's a major thing. And CNC is the father of automation that takes materials and reconfigurable into precise form. And finally, at last is our field, industrial robots. It's actually ranging from delicate to precision tasks, such as maybe you can even use the robotics for fitting the small parts of watches, and to the hazardous tasks such as fueling the chambers of nuclear reactors. And these are the most commonly used technologies. There is a lot of technologies available, and these are the most commonly adapted technologies such as CNC machines, 3D printer. 3D printer is the most advanced one. Even we can build the entire home within 24 hours. So that's an enormous technology, 3D printer. And for heavy manufacturing, we may go with CNC. And now, due to the evolution of Industrial 4.0, a lot of hardware automations is being integrated with IoT technologies. That's what I would like to share with you for the next 30 minutes. So let's make some curiosity about how big this market is. So industrial robots, according to like Industrial Internet of Things, according to the Accenture, you may know the companies, they actually put forward that industrial IoT might contribute around 10 trillion USD dollars to the global economy by 2013. So sensors, material tracking mechanisms, 3D printing, automated product design, robots, and wearables, according to the study, might help manufacturers to cut cost and boost production. So predictive asset maintenance has the ability to cut equipment and machinery cost by up to 30%, and while also reduce breakdowns by 70%. So currently, a slew of organizations promises to help industrial equipment operators and engineers with anything from machine operation and maintenance to enhancing production operation. So in this section, before starting the exact points and topics, so I framed 3 questions, and maybe this session will be able to find out, like, we'll need to find out the answer for the questions I framed. So these are the 3 questions I framed for this session. Maybe it may be the output answer, maybe the outcome of this session. So what kind of AI applications are currently being used in industrial automation? What tangible outcomes has AI brought to the field of industrial automation? And finally, are there any recurring themes in these efforts to innovate? Like, what impact might these developments have on the future of industrial automation? These are the 2 different fields. Maybe take maybe years or months to explain about these technologies, because industrial automation is completely different and AI is different nowadays. Like this session, just I'm going to explore how this AI is going to help the industrial automation, like how this AI is actually implemented in robotics. What are the possible outcomes we got? What are the transitions the industries got after this pandemic? So the goal of this program is to provide, especially the goal of this session, I'm just take this. So the goal of this session is to provide to manufacturing leaders or those who want to become an industrial automation entrepreneur is an understanding of what they can currently expect from AI and industrial automation in their industry. So if you want to start an industry, I think few things I would like to share with you in this section. So I personally believe that this 30 minutes maybe will provide some manufacturing executives or budding entrepreneurs with information that they can reliably transmit to their executive team, so they can make well-educated decisions about AI deployment into their existing automation plan. So at the very least, this session is aimed to reduce the amount of time where the manufacturing executives spend studying about AI startups, which like with which they might collaborate to develop an industrial automation solution. So a few case studies I would like to share with you. So from that you can think about like whether we can implement these things for our plant, or if you want to implement these kind of technology, I think the case studies is really going to be useful for you. The first case study I'm just taking is about the Siemens. You know that Siemens is a German based company, leaders in industrial automation that offers so many technologies. And in this session, I just would like to share one more product from Siemens. And don't think about, I'm not promoting any product, just for the for a real-time example. Because like you may know that we have billions of applications and softwares are in the Google Play Store. At any point, can you think about like, is any particular software or application is available for the industrial purpose? So this is what I'm going to share with you. So Siemens is offering a MindSphere platform, a cloud-based operating system that allows machines and equipments in a factory to collect data. So Siemens believes that the machine learning based analytics software can help manufacturers monitor the status of their industrial assets. So sensors, according to the Siemens, collect data from different units and upload it to the company's database. So this information is subsequently sent into the MindSphere machine learning system, which informs and which will be updated in the MindSphere dashboard analytics. For example, maybe you can take an example, a battery factory industry running on a MindSphere platform may be designed to generate or produce 1 lakh batteries per day, but sensor data may reveal that the production has decreased in the last 2 days. So this data is shown on a facility maintenance manager's computer screen in the form of visual charts. So may also reveal which machines are underperforming. So this is what the MindSphere is capable of. So MindSphere may also run on diagnostics on the machine that is not operating well. When the machine learning model underlying it detects a problem, the MindSphere may notify machine maintenance personnel and recommend that the machine may be repaired or retired. So I would like to show one video about this MindSphere platform. I just turn on the subtitles so you can get to know what exactly this software is about. Next. Okay. I will share the screen once again. Okay. So I just turned on the subtitles of this
One of the
video
things we
also.
say here in Charlotte is we power the world.
Maybe you can just hear the audio of this.
We manufacture and service steam turbines, gas turbines, and generators. One of the key things is keeping production running so we could do a better job understanding when breakdowns occur. Even today, about 20% of our time is reacting to breakdowns. So here in Charlotte, MindSphere is helping us understand status on the work being done on the 3 machines we've got it connected to. We can see when work starts, when it ends. We can see that remotely. We can see it from my office or from the plant manager's office.
Charlotte is very significant for us from many perspectives. It's a large plant. It's got a lot of legacy equipment. So we want to be able to prove that we can connect not only these modern equipment, but equipment which has been around for 40 years.
We've got machines that are manufactured all over the world. The control systems are made from several different suppliers. We need to be able to pull together the information from all those different types of machines. Once that information is in the same location, we can analyze it the same and we can do tremendous things.
Charlotte has a culture of being open to change, and we really push hard for innovation. We have a great fertile ground for ideas and projects like MindSphere to come and bring innovation to manufacturing.
MindSphere is an end-to-end solution. It's an IoT operating system. It consists of 3 layers. Connectivity layer, where you connect plant and machinery. The infrastructure layer, which is the cloud infrastructure layer. And the application layer, where you have all the value-creating applications.
MindSphere is more powerful than our competitors because MindSphere allows us to connect easily with our existing infrastructure.
So you can connect a machine and get data into the cloud within 15 minutes. Think about the consumer world. We're talking about millions of apps in the Apple Store, right? We want to do something like that in the industrial space, call it the Industrial App Store. We are already working with 30 or 40 different partners who are generating apps. I think that's where this is headed, and I think the industry will embrace that. The manufacturing world over the last 20, 30 years has been producing a lot of data. The problem is nobody's harnessed the richness of this data. And I think that is what the industrial Internet of Things is going to be doing. That's how it's going to change manufacturing in a big way.
And some people might ask, well, we've been running our machines in our factory like this for years. So why would we all of a sudden be interested in data? And the reason why you should be interested in the data is because it allows you to make better informed decisions about your machines and about your operation.
The maintenance team here in Charlotte is extremely excited about MindSphere. A lot of enthusiasm and excitement about what we can do with this type of process and this technology.
I work with a lot of people who are big dreamers, and they see the future value of where we're going, and they're always coming up with new ideas and new ways to innovate.
Okay, so this is the videos about MindSphere platform. It's an industrial IoT. Okay. I just like to continue from where I left. So yes. So MindSphere, according to the Siemens, may employed in a range of industries, including aerospace, automotive, and energy. So Siemens claims that sensors and MindSphere helped Another interesting example for you, Heathrow Airport. So improve their luggage handling systems by decreasing system downtimes and interruption. So according to the firm, almost 76 million individuals went through the Heathrow Airport in the year of 2016, and majority of whom had luggage. So Heathrow wanted to move the luggage handling systems maintenance from scheduled to as needed. So Siemens workers monitored the systems by installing several sensors on crucial components, and the sensor captures the data on things like acoustics, which could indicate a problem with the system and sends into the MindSphere platform on a regular basis. So although the outcomes of integrating MindSphere, I'm just not able to find out exactly in the case study, but I just have taken a few things from the asset manager, and he says that over 80% of the customers are already rated Heathrow as a very good or exceptional. So this positive feedback serves as both validation and motivation for us. So we wish to increase our high standards with Siemens as one of our innovative partners. So Siemens, this MindSphere platform is actually being implemented and used by so many industries across the world. So this is one of the interesting case study where industrial IoT actually evolves the other technologies in the industrial automation field. Maybe can take this is completely an industrial automation. And next one is about another interesting case study is IBM. You may hear about the Watson, IBM Watson. So with image identification and machine learning analytics, IBM claims that to be enable mining companies undertake different subsurface analytics, and that could potentially cut drilling cost, improve mineral exploration, projections, and speed geological discoveries. So the tool, the IBM Watson, according to the IBM, allows geologists to do subsurface analysis for geoscience data interpretation, reservoir exploration, and the mineral discovery, and so many things. So users can accomplish this by typing a query into the platform's search interface. Then the keywords will be run through the search engine's algorithms. So the keywords will be used and used to get some geological data repository, which contains structured and unstructured data, like drill database, block models, geochemistry, and geological shape fields, X-ray fluorescence data. So the machine then generates a graph with a mineral content forecast. So by developing a machine learning model to anticipate gold mineralization inside a given region in the mine, IBM claims to have assist a gold crop in another company, is a gold mining company, in increasing the productivity of its existing exploration and production operations. So the algorithm search through the repository for multiple geological data when combined yielded a well-informed forecast. So these are some of the correlated topics. Maybe I am also not aware exactly about these things. These are the different data like where this IBM Watson is collecting. So the data was gathered from a variety of sources and in and around the target region where they are going to do the mining process, including drill hole data, chip data, maps, geological models. So a graphical representation of the expected gold content in that location was provided by the software. And IBM, that's a gold crop company, claims that IBM Watson has assisted the corporation in consolidating it 140 block models, including different unstructured data into a single database. So the difference between the implementation of Watson before and after is the company could only load 2 or 3 block models at a time previously. So this is what the major difference they got. They got more number of decisions and more number of data so that they can make a consolidated decisions through this data analytics platform. So this is another interesting case study. And next is about our field. Is the most advanced robots currently is a cobot. It's not a robot. Maybe I show a few robots. What we develop for the education purpose. You may see that this is a maybe it's too large to show all the things inside my frame. So this is an industrial robot, a traditional industrial robot, a 6-axis DO robot. the most of the industries are adapting these kind of robots. But in this case study, I would like to show few advanced robotics named as cobot. It's a collaborative robot. The difference between the cobot and robot is like anyone can walk along with cobot. That is the major feature. Like it has the inherent safety feature, so it will not disturb the people who is walking around us. But in traditional robots, we
One
need
request, Sriram,
Yes.
can you close your screen and show your video? We can see your robo also.
Okay, sure, yes,
Because you showed it and it was half visible.
definitely. Okay, maybe I will. Maybe even I will operate it.
You can operate and show.
Okay, so you can see this. This is a 6 degree of freedom robot, and this is completely be trained by a lead-through method. Lead-through programming is just like using a teach pendant, or by joystick we can move the arms. So the robot will store all the points and do the repeated action. So it has 6 degree of freedom. It means like it has six different motors. So using the joystick, we can able to control it. I am just turning it now. You can see this. Has using the joystick, you can see this. It has different joystick controllers here. So we integrated this. Using this joystick, we can able to control it, and maybe so we can see this. This is the finger, and we can able to control it. So different actions. So can able to move it. So it's just like it's a general way of programming, because most of the operators in industry is not aware technically, like because the robot programming is consists of different methods. Like this is one of the easiest programming method where anyone can operate it. So there's other way of programming where the professionals can do it, like simulation based programming. So using the simulation tool, we can design the entire environment. So we can see what exactly is going to happen in real time before implementing it. That's the power of simulation, but it requires a lot of knowledge and software expertise. And this is another robot. I think Saravanan described about this, a mobile robot. And this is purely for an education purpose. We designed purely for the faculties and for the engineering students to explain what exactly the different types of robot. This is a mobile robot which is used to carry the loads from one place to another place. Maybe you heard about that word AGVs, automated guided vehicles, and this is also an autonomous vehicles. So it will travel without any human intervention. So it can able to find out obstacles in front of it using different sensors. Around 5 different sensors is integrated in this mobile robot. So through this, it can able to map its own environment and just travel without any like support required from this human. So these are some of the common robots used in industries. And the case study, I'm just going to show one of the advanced robot recently, which is an advance for us, like the people from India, maybe some of the professors attending this session, maybe from the abroad. So they may know about this robots, collaborative robots. So I just continue. Yes. Okay. So rethink robotics. So Cobot is actually a collaborative robots, and Universal Robots is the first company they installed. I think they're the first company they just invented the collaborative robots due to the evolution of Industry 4.0. And the Rethink Robotics is in another company. You can see this a product from Rethink Robotics. Yes. So Sawyer is the product of Rethink Cobots. Sawyer is a collaborative robot from Rethink Robotics that works on intro software. So Sawyer, according to the Rethink Robotics, can help factories and industries achieve increased efficiency and product quality by using the machine vision system. So Sawyer, according to the Rethink Robotics, is equipped with Cognos vision system that allows it to recognize what type of object this is, and it will check the parts using the object detection technology. So this vision system, like you may see a face like a tablet, that is the vision system. So this vision system captures the photos of items to be handled and sends them to the another important controller named as Robot Positioning System, RPS. And this is a program This RPS is a program that monitors the robot's environment for any changes or allows the operator to adjust its settings. And even you can integrate the external sensors and external cameras into this cobot. And I will tell one of the key features of this rethink robotics. So relocating soil from one portion of assembly line into another, for example, necessitates the adjusting the vision system to let the soil to detect a new position of the objects need to pick position and return it in the new work area. In case when some human operators bumps into the table or conveyor belts or cobot itself, the physical position of the the physical position of the goods to pick up and place may different from what is logged into the vision system. So these small adjustments can lead the cobot to pick the parts incorrectly. So when this occurs, this RPS, that is robot positioning system, must be readjusted to let the vision system to identify the object's new location. So you may see this Sawyer face is a tablet which also acts as an interface for the robot operator to make modifications. So operators can train the robot using the intro software by moving its arm and demonstrating the pick and place and hold movements. So Sawyer may also assist the operators operate a machine while it's in operations, such as execute different types of process such as plastic injections, blow molding, testing, quality inspections, and attend to the metal stamping or metal pressing process. So these are the common procedures used in the automotive supply chain, like metal fabrication, general manufacturing, packaging, and factory automation for plastic. And for this case study, I would like to show on another video that is like regarding this RPS. So initially, the operator will train the robot to detect what exactly the object position is. When someone bumps into it, like I mentioned that when someone bumps into the table, the position may differ. So using this RPS, how this robot learn the new position and adapt to the new working area. So that's a biggest, I think I saw among the other cobots, the major future I saw from the other robots. So I show another video to participants. So just a minute, I will take the video. Okay. And the robot I shown shown with you in real time is completely is a traditional robot. It's purely a traditional robot, which may be seen as a new one for you, but I openly said this is not a most advanced version. Cobot is the most advanced version of robots. So all the manufacturers currently, they are shifting their robots to the new evolution. So just share my screen once again. Yes, with sound. Okay. You can see this. Now the operators move the robot, and for the process is going to pick the hinges, and it's going to load the it's going to pick the cylindrical rods and going to load into the CNC machines. Initially, he uses the intro software to train the robot to capture the position of the machine and also the position of the object. You can see this using the vision system, Cognos vision system. It captures the position. Only 15 seconds is needed to train. So once it is trained, it will do the job. You can see now the training is completed. So the robot will do the job repeatedly for a longer period of time. Yes, now he went. You can see this. You can see this part. Now the operator bumps into the table. So you may see that new location may be a problem for the robot to identify the new location. But using this RPS, you can again train the robot. If in future, if any changes happen, it will be able to adapt to the new location. That is the major future you may see. And this is completely about the industrial IoT, the integration of industrial IoT and AI technology. So this evolution is not only for the commercial products. This is also for the robots. Every technology needs to be evolved over the period. We cannot use the same robot for a longer period of time. This is completely a different world. So this is the robotics technology is going on currently. So this is another interesting case study about the AI adoption in industrial robots. Okay. This is what we've seen. So, okay, next. So the Rethink Robotics claims to have assisted NASA Obla is another company. It's want to automating its manual labor intensive production lines. So currently they have two robots. Like before installing the Sawyer robot, they have two robots, Sawyer robots. And now Asalbay has deployed Sawyer cobot across all their plants in the world. So according to the case study. So Sawyer assisted in automating the manual assembly lines and packing off around 18,000 pairs of hinges per day. That's a major advantage the company's got. And more importantly, I'd like to show a few things. And due to this enormous technology, they got around 149 million fundings for the next level of inventions from all across different companies such as Bezos Expeditions, Charles River Ventures. So around they got collected 149 million fundings for their own technology. So these are the most advanced version of robots, and so now I would like to share a few things about the basics of robotics, like different types of robots are available in the industries. A few robots here I shown is a fixed robots, that is the industrial robots. What I shown as a prototype model, that are all manipulated robots. Especially you may see this type of robots in the manufacturing industries for different process such as assembling, building, painting. So many processes there. And mobile robots is the most advanced version. Nowadays, what the companies are thinking is, you may hear about another company, Boston Dynamics. What they are doing is, I shown two robots, right? Here is a mobile robot, and here is an industrial robot. So they integrated the industrial robot on the top of mobile robot. So normally the industrial robots cannot move. The base of the industrial robot fixed at one point, so it has certain reach. So,
Mr. Sriram?
Yes, ma'am.
Yeah, just to bear with us, to interrupt you, if we can have 2 more minutes to have this presentation.
Sure, ma'am. Sure.
Yeah, only
sure.
Because we have hard pressed on time.
Yes, ma'am. Yes, ma'am.
No problem. Please. Sorry to interrupt you. Yeah.
Yes, no problem. So,
please go ahead.
Yes, ma'am. So these are the different robots, like the fixed robots, mobile robots are available, and maybe so. Due to this technological evolution, like industrial evolution, the robot technology is being also, this is also evolved. The major constraint the operators got from the traditional robots, they are very heavy and they need professionals to train. And it's very difficult to deploy, and more importantly, it doesn't have any inherent safety features. And these are the problem statement taken, and it's been solved by the Universal Robots. And they're the first company, I already mentioned, that launched these type of collaborative robots. And collaborative robots comes with an ISO standards, ISO 10218-11 certification. So it's the default, it comes with the default ISO standard. So anyone may operate along with the cobots itself, and that's a major future. And maybe I just would like to show a few other cobots. And this is from the dual arm from ABB. This is also one of the advanced cobots, especially used for electronic assembly, like the PCB boards, like soldering purpose. They are used. And this is another product from Rethink Robotics. Baxter uses the vision system, and mainly they are using for manufacturing and production process. And this is another cobot used for the laboratory purpose, like desktop applications. We may use this type of robot. And next stage is completely humanoid based cobots, a multi-purpose robot. And this is the UR robots, like the first cobots in the world, Universal Robots. And this is a model UR5. And these are the benefits of cobots. Like they can replace the repetitive task. I am not comparing the cobots with a cobot is a replacement of traditional robots. Heavy jobs is always required traditional robots because cobots can able to lift maybe a 50 kg maximum, but heavy robots you may see that KUKA robots. Maybe if you have an Instagram, maybe you might check with the KUKA robots. Recently, I saw a post, a KUKA KR1010 robot can effortlessly lift the Audi car, which is nearly around 1000 kg within a few seconds. So traditional robots is somewhere is maybe fit into the industries, and cobots is have a different facilities, and more importantly, this is affordable. The cobot is affordable for the countries like India, because we are all dependent on micro scale, mini scale industries. So they are not affordable to invest 20-30 lakhs on a traditional robots. But according to this cobots, is very cheaper, and anyone can learn, because programming is not like a Python programming or not like any embedded programming. So it's all like a just drag and drop function. So anyone can able to solve it and maintain it very easily. And more importantly, like a product you are ordering from an Amazon, you may deploy within few minutes. Similarly, if you're ordering the cobots, you may assemble within a few minutes. But traditional robots requires a week to install and deploy it. So these are the major difference between the the traditional robots and the cobots. So I think that's all the things I would like to share with you. So thanks for listening to me to my presentation. So thank you once again. So if you have any questions, maybe the time is not available, maybe I will share the mail ID with the expected coordinators. You may just mail to me, so I will definitely come back to you. Thank you again. Have a good day.
Thank you, Mr. Sriram. That was definitely extensive for us. And yes, thank you for taking your efforts in fact, presenting few of those live to us. We do have a couple of minutes to take few questions, because we've already received few questions via our chat. So we'll go on to pertaining to Sriram's topics, Mr. Sriram's topic, sorry. What is the role of Mendix introduced by Siemens? This has been addressed by Mr. Venkata Subramanya.
Okay. Thank you, sir. Venkatesh Subramaniam, sir. So what is the role of the MindSphere? Maybe the software name is MindSphere. And the MindSphere role is to collect all the data, like all the data. So we do some analytics and will show what exactly the machine is doing. Like you may hear about some of the interface software such as SCADA systems, LabVIEW systems. So the people will sit on the cabin. They can look over all the process from a single end. But using this MindSphere software, you can even get the predictive results, like predictable results. These are the things is going to happen. The maintenance date is coming, so you have to like maybe lubricate it. So some predictable results you may get. But in the initial level of automation, you get only the results, maybe the alarm, maybe during the breakdown only. So if you get these possible results, you may avoid a big breakdowns. And as you know, how big problem it creates, especially in the manufacturing industry, when some machines are being shut down, means definitely will create a lot of problems. So this will give is a completely machine learning based IoT software, which will give the predictable results, and it's really going to helpful for the industrial manufacturers to analyze the problems and try to solve before a big breakdown is going to happen. So this is a short glimpse about the answer, but technically I can explain a lot of things due to the time constraint. This is a short thing. Maybe I'll just mail what are the other possible things it will give for the end user.
Can we quickly go to other questions?
Yes, definitely.
Yeah,
So yes.
Yeah, we have one more from Vanessa Johnson. Is that the robots can be enabled electrically or by artificial intelligence?
Yes, this robot I shown this completely is an electronic based. There is no artificial intelligence technologies implemented in this. Mostly in traditional robots also there is no AI mechanism is being implemented, and this is completely different upon what type of applications you are going to utilize. So industrial robots is these are all industrial robots, and these are all like is in big size. They doesn't have an intelligence sense. So if you require a lot of intelligence and things, maybe you can integrate the AI and machine learning algorithms. And mostly industrial robots are pre-programmed. They will know what they are doing, but they don't know who it's going to work with. That's the major problem is being with industrial robots. So I think basic electronic things, we can utilize the electronic materials and we can build the basic level of robotics. So this is what.
Okay. Okay. And we have one more from Venkat Subramanian again. What is the concept behind ASIMO Robo introduced by Honda Motor Corporations?
Yes, sure. It's really a good question. ASIMO is completely a humanoid robot. The topic is very different from what I am shared with you. That is completely a humanoid robot. That's separate field. Is completely about the machine learning, neural networks, and this is like training the training model, like trainer model. So they have been in the research field for around 30 years to build an ASIMO robot. This is the first humanoid robot for your information, first humanoid robot in the world. ASIMO, and this ASIMO is used, is especially designed for the elder people, maybe for the caretaking applications at their
The next presentation is going to cover that.
Yes. Okay.
Yeah. Thank you.
So,
thank you, Mr. Sriram.
Yes, have I missed
Thank you
any
for your time
questions?
again.
Okay. One more question.
Yeah.
I think I missed this. Very similar to how a JCB works. Exactly. It's like
Yes.
a JCB. Like we can use instead of using the joystick here in industry, we are using a teach pendant. Like through this teach pendant, like that's a name. A technical name is power lead through method. Using the teach pendant, we can able to control the joint motors, and the robot will store the points and do the process and again. So this is what a simple method of programming in industrial robots.
Thank
So
you.
thank you. Thanks a lot. Yes.
Thank you so much, Mr. Sriram.
Yes, thanks a lot, man.
Yeah. Okay. So from it's been a real learning part so far, and again we move on to the next part of the session. We would like to welcome Professor Vijay Kumar Gupta. He's a mechanical engineer by qualification, and he's currently a professor at the Indian Institute of Information Technology, Design and Manufacturing at Jabalpur. Professor Gupta obtained his master's degree in reliability engineering from IIT Bombay in 1994 and PhD degree from IIT Bombay in 2003. Professor Gupta has interest in the area of vibrations, condition monitoring, smart structures, FEM mechatronics, and robotics. He's a recipient of K. Suryanarayana Rao Memorial Senior Student Award for R&D in Smart Technology during the year 2003. He's also a recipient of JSPS Short-Term Invitation Fellowship. He has published more than 20 journal papers and authored 3 books so far. So robots are here to augment the capabilities of healthy individuals, example, improved walking efficiency, in addition to assisting those with muscle weakness, or patients who suffer from physical or neurological disorders. Professor Gupta would give us more insights on this topic for the day on robotics. Welcome, Mr. V.K. Gupta.
Thank you, Priya. Thanks.
Time is all yours. Yeah.
And thanks, Krishnan, for giving me this opportunity. So today I am talking about the wearable robotics, and that is basically, you can say, the first talk was on SCR. So it is the application of SCR, wearable robotics. And as we are moving towards the industry 5.0, so in human and robots, they are working together. So this wearable robotics is one of the area where the researchers can work. So I am sharing most of the things which are more research oriented rather than the basics in this presentation. But I will be introducing some initial things basically. So wearable robotics, other name we know is the exoskeletons. So they are basically the robots which can enhance the user's strength and endurance. So research, they can be used for the weaker persons to help them doing the daily jobs, or they can be used by the other persons for doing the repetitive job in industry or to lift the heavy loads and other things basically. So there are various applications of wearable robotics. Some of them are listed here. First is the military focused research. So pick and place of heavy objects, because we know that when these soldiers, they carry the bullet, gun and bullets, etc. They have to carry heavy loads. So these wearable robots can help them to reduce the burden while marching at high speeds to rough terrains, because this heavy load that restricts their movement at high speed. So these robots can help us. Another research orientation or the application area is the rehabilitation, where these exoskeleton or the wearable robots can support physical therapists in helping a person regain full or sufficient function of body movements. But particularly when the persons are subjected to some stroke, they need the rehabilitation. So in that case, these robots can help the persons to regain their full or sufficient function. They can serve as the permanent system that can substitute the parts of the user's body. Certain people, they lose some of the limbs, maybe the upper limbs or the lower limbs. So these robots can help them. We know the example of the Blade Runner. So that is helping in running the athlete. They can provide assistance to elderly people to carry out. As the age increases, the elder people, they lose the control over different things. So these robots can help them to performing the daily living activities. This is one example where you can see that there are full exoskeleton is there. It contains the support at the legs as well as the hand area also. So we generally divide this exoskeleton into two parts. One is the upper limb and another is the lower limb. Most of my presentation will be focused on the lower limb. The HAL-5 was one of such assisted robots. So let me just show you the video. Just a minute. This is one of the side. It is having some problem in loading. I just wanted to show you some video which is showing. Okay, sorry for this. So this is HAL-5 which has been developed, and you can see here.
Hybrid assisted lift allows its user to easily lift a 40-kilogram durable case like this.
this both hands and legs, they are helping the person to. This is another example where elderly persons are being held by this exoskeleton to move forward.
This hospital in Yamaguchi, Western Japan, has been leasing this robot suit for about $2,000 per month.
This is how this suit, exoskeleton or wearable robots, they are being fixed, and then they allow the person to move.
Is 74 years old, suffered a stroke twice. With his lower body paralyzed, he has been unable.
The person on wheelchair can now, you can see that it can climb the stairs also with the help of this exoskeleton.
Begins to assist the leg muscles. This occurs the instant the person thinks to.
So this is how the muscles are being strengthened. And then what happens is that when we move this, the system detects the movement, and then it supports the motor, starts supporting the legs and other things. Basically.
He is also the CEO of conveying the electrical signals to the motor. It is far short of being practical.
So heavy load you can carry on.
But HAL now weighs less than 10 kilograms, half that of the test model, and a compact battery pack.
I can stop at this point this video and I can move to the presentation. So my focus is more towards the lower limb exoskeleton. If we see the classification that was given by Rupal in 2017, they have defined the exoskeleton into two categories. One is the medical and another is the non-medical. Okay. So I already discussed the soldiers, for workers in the industry, for elderly persons, and for general purpose. We can use this non-medical exoskeleton. And in medical, it creates a lot of applications, just like for paraplegic persons, for rehabilitations, for amputees and disabled persons, and for compensations. If we see this type of paralysis, basically the persons, they may suffer from the monoplegia, in which only one part, either the upper limb, means hand or leg, it will not work. So in that case, we can have either the upper limb robot like just exoskeleton or the lower limb exoskeleton to help the person to overcome this problem. The second type of paralysis is known as the hemiplegia, in which one part of the body, either the left or right, it will be affected by, and then it becomes weak, or maybe sometimes it does not work at all. So in that case also, we can have the wearable robot or exoskeleton, which can be helping the part which has become weak. We can place it, and then it can help to perform the daily routine and other tasks. The paraplegia, where the lower part of the body does not work. So in that case, we have just seen the video. We can have the exoskeletons which are mounted on the lower limb, and then they can assist the person for performing the daily task. And in quadriplegia, the whole body, basically only the mind is working, and the whole body does not work, and then we can use basically some signals like EEG and EMG to detect what mind is requesting, and accordingly we can move these exoskeletons also. So when we use these exoskeletons, one of the sensors which is generally being used is either EEG sensors or EMG sensors. They detect what mind is asking for, and then according the exoskeleton can work. Sometimes the other way to work with this exoskeleton is that they detect the movement of our limbs when they are trying to strengthen the part, or they are trying to help the person in lifting the more load and other purpose basically. So in that case, they see the movement of our hand or leg, and then the motor will actuate and that will assist the person. So I can skip this. So based on this studies, basically some work has been done in our lab and I am presenting that. So first work is the assistive lower limb exoskeleton. So before that, actually what happens is that if we see the movement of our hip joint is a ball and socket joint. When the hip is loaded, the acetabulum deforms, increasing the contact area. So this will start deforming and the contact area will be increasing. So it is not exactly predict, if we are not able to predict the actual movement motion of the hip joint center, because the center will be also be because of the deformation of acetabulum, this center will be changing. Generally, when there is some injury to the hip, they just replace this hip portion with a fixed center. But the actual problem is that this deformation is not taken care. So the persons, they can move straight on a straight line, but while taking the turn, they face the problems. So this structure prevents an exoskeleton design with technically equivalent solution to align instantaneous center of rotation of all joint axes. So these are the motions involved. If we see that we can have hip joint movement, that is flexion, means we are moving the leg front and backward. You can see this is front movement, this is back. Then we can have the rotation. So it can be leg is from this position, it is turned like this, external rotation. And in this case, it is moved inside. So internal rotation. Then we can have abduction, in which the leg is spread. In adduction, the legs are crossed. So these movements, in a normal person, they are perfectly taken care by the hip joint. But if there is some injury to the hip joint, in that case, we require certain external way to replace this, and one of the way is the exoskeleton. So these exoskeletons can be designed according to that, but normally what is considered is this center is fixed, while we require a movement in this center. So researchers has this worked on this. So misalignment compensation for any rotational degree of freedom. So you can see these lines there. These are the misalignments basically. And these misalignments, when we are moving our legs for either rotation or for abduction or adduction, these movements are required for the hip joints. Keeping this in mind, actually, if you see, this is the simplified view. This is the exo. One is the exo, and suppose this is the human limb, and this is the cup point. So when we move our leg, the movement of the leg about this point will be something like this. While if you see this exo, it is moving like this because this center is fixed. So in this case, the center will required is the moving. So we are not able to get the perfect movement which is required by the human leg. So in such cases, actually the person who is wearing this exo, it will feel some discomfort because of this differentiation. If you see this difference and this difference, because of this differentiation, they will start facing the discomfort. So what is exactly required is that is shown here. If this center, as we move the leg, this center is moving. So accordingly, if we move this point, hip joint point, means the center of rotation is moved in this direction, then we can achieve this perfect. So now you can see that the difference is uniform throughout. So this is one of the target which is being explored in this work, and then accordingly the various researchers has also given their solution for this. If you see here, hip joint with 5 revolute and 2 prismatic joints. So it is having the 5 revolutes and 2 prismatic joints in this case. It does the passive alignment of the internal external rotation axis using supplementary joints. So these joints are actually helping the person in achieving this. You can see here these motors, they allow the movement of this hip in this direction. So there is a sliding action and that can be taken. Then there was another solution where the 5 revolute, 3 prismatic and 1 ball joint has been used. That has been shown here. Movement in the sagittal and frontal plane depends on the rotational movement of the whole hip, and all 3 axes of exoskeleton should be intersecting at the hip centers. So with this, they tried to make a mechanism. Basically, I am from mechanical, so mechanism are more popular for us. We try to incorporate the mechanism wherever possible so that the desired motions can be achieved. So this is able to give that. So we require 2 more types of the slider. One is the hip linear slider and the curved linear slider. Hip linear slider keeps the joint aligned and reduces discomfort at the attachment, while the curved linear slider allows the turning maneuver, basically. So this is the video. It shows you. There is a slider which takes care of this, and then you can see the person can move easily. So the data has been recorded, and when no sliding action was there, no compliance was considered, this was the movement. You can see here, this is the data where the stress is more. And then when compliance was incorporated, this is giving me more smoother action. And these are the videos. That is for the turning action, basically. These videos show the turning motion. The next work was for the strength augmentation. So in this work, basically, the knee joint has been explored. So this is the structure of the knee joint. In this case also, if you see the movements, basically the various researchers, they tried to incorporate various mechanisms to take care of the knee movements. Knee, again, when it is rotated, there is a sliding action and which need to be compensated while movement. So, for example, this design, when it is moved, it is having a sliding action as well as the rotational. Or you can have a shape like this, so which take care of the linear as well as the sliding actions. So basically, this is what is required. This rotation as well as the sliding action is required. So a combination of these two are required for the proper movement of the knee joint. So for this, what has been done, first one setup has been derived to know how much movement is there between these two joints, and then you can see here there is a movement, there is no movement of the slide, no sliding, then sliding opens, and when we are taking it back, it takes a different path. So you can see that a curve is obtained in this case. These are the observations from the experiment done. So I see basically the instantaneous center is continuously moving in this case when the knee is moved, and that need to be compensated in the design of the knee joint, proper knee joint. So accordingly, the system has been developed, and then you can see this. This is another video. You can see the person is moving, and there are motors mounted which are helping the person in proper movement. And at this stage, if you see, it is taking the turn also easily. So this was the lower limb exoskeleton. Coming to the upper limb, we can have the support at the shoulder, we can have support at the elbow and support at the wrist. So upper limb exoskeleton, just I am briefing. We can have single joint exoskeleton or we can have multi-joint exoskeleton. They can be electrically actuated, they can be pneumatically actuated, hydraulically actuated, or the new materials like state memory alloy can also be used for such purposes. I had already discussed this. There are different joints we can explore with this, and they can be used for different applications. But I am not going into details because of the. Thank you for question.
Thank you, sir.
Thank you, Professor. Thank you so much for your presentation. We have one question if that could be addressed from Vanessa. On average, how long it takes to make a wearable robot? What is the average cost and the average usable time?
Actually, wearable robot development is taking time. When you try to develop the robot, it takes a lot of time because you have to study the human motions, and then accordingly you have to design it. The problem is that human to human, the movements are different, the body structures are different, so you have to take care of that. So that takes time, but once the technology has been developed, there are ways you can compensate for the different body things. So the developing stage, it may take 2 to 3 years, but after that, the making of the robot is not that big task. So it can be made according to a person, it can be developed within 3 to 4 months also. Average cost, it is varying basically at many places. So as I studied, it varies from some millions to millions, basically, in the millions, in rupees basically, right? And then the average usable time, if it is properly designed, then you can wear it for the whole day also. But if it is not properly designed, just like I given the examples that there is a sliding motion along with the rotations. So whether it is at hip or whether it is at the leg, knee joint, then you will start feeling discomfort in 1 hour or so also. Is the wearable robot available in all countries? I don't know about Caribbean basically, but they are in market, and there are companies available which are supplying these robots.
Okay.
Thank you, sir.
Thank you, sir. Okay, we have one more question to share the link. We will be sharing it before we close the session. I'm forced to move quickly with the session because we are running behind time. Next, we have our final speaker for the day, Dr. Krishnan Umachandran. I would be taking much of time, but I'm just keeping it very short. He's basically a mechanical engineer. He holds a degree in mechanical engineering from the University of Madras, and he has also done his PhD. He is experienced throughout the value chain of switch, fuse gears, railroad, passenger cars, industrial valves, beverages, to name a few. And he's currently the general manager, organizational and development at Nelcast India Limited. Sir, over to you. I don't want to take your time. Yeah,
No
we
issues.
have much to hear from you. Yeah, thank you.
No, I'll quickly rush it because people
Yeah.
will also be quite tight. So what
Yes.
I'll do is I'll convert this speech of mine or the presentation of mine also into a kind of a conclusion, so that people can really understand how and where we are. Hope you can see my screen, right?
Yes, sir, we can see, please.
Right.
Thank you.
My topic is on the robotic application on SOC. SOC means source of contamination, and HTA means hard to access areas. I'm specifying this towards hospitality industry, the restaurant in a hotel or in a hotel. So you will see more of pictures rather than me talking. Wherever you see content, I will just push through with the right kind of a keywords that needs to be explained, because you already heard many from the speakers earlier to me. Now coming on the robos. Robos are always thought that it is going to second a human being or it is going to support a human being. But robos have limitations. Let us understand that first, because what robos can do is based on our thinking, not by itself. So it has its own limitations. So to expect that a society wants higher efficiency, higher automation, replace human with cost and labor, all these things are having a limitation. So let us understand where we can put this robo into place. So now for a robo by itself cannot have an intelligence. So you need to create an artificial intelligence to do auto working. Normally, whatever presentations we saw up to now is not auto working. It is a physical working based on the force and pressure with a human being, which is wanting to give on the machine. And then there is sense or the perceptron that a robot requires, the ability to move and power by itself. It's required from a robo, and the dependence factor, like any other machine, like a car, when you want to start a car, it should start. No, so you need to have reliability, you need to have consistency, you need to have repeatability, remove out the monotony, and take up the novelty and interconnectivity. All these things are required, provided your product can get an ally of robo and then work along with it. If this is done, then the robo's expectations or the robotic implementation expectations are fulfilled. I'll go to the case straight away. I'm going to use robos in restaurants. Don't worry about it. It is already implemented. So many of the pictures which I'm going to show you is in Chennai and one or two from US. I picked up the pictures and where this robo is onto its actual working. In a restaurant, when you want to have a robo, what is required is the restaurant is going to be not of the same size, same kind of a working. It is going to become a smart restaurant. So when you want to have a smart restaurant, then the services should be delightful. It should be happy for people to enjoy, see, and go with the relishment of novelty. But the functioning of a restaurant is going to be the same. You're going to order food, you're going to build the process, and then take care of the restaurant process, and then give a customized service. For this, you require space like reception. You will have kiosks, you'll have a restaurant, you'll have a kitchen, you'll have a fun center, and a clock room for keeping things and all the stuff. So this thing is not going to change. It is going to get amplified or enriched in its link. See here, for when you have a restaurant, see, putting on a robo is for making money, for enriching profitability. It's for making a betterment. So variables in a restaurant are, one, they depend on people. They depend on the orders, what the people who had come to make, and the more money that needs to be actualized. So this is more important for a project where a robo is going to be introduced into. So here, when you want to do it, then you need to have a turnover of table. So more tables have to be occupied, and every table which is occupied should get more revenue. So this is what is called as table occupancy. When this can be maximized, then you have the people. People cannot be made and churned out into the same process. They come in a different group size. They have a frequency of joining. They have informality to be controlled. One will move from one chair to another, one table to another. And at the same time, there will be some individuals who want to be alone, like due to young, old, or sick, whatever it is. And then there are certain people who are adjusting. They can move from anywhere to anywhere. So, but for all these people, what you need to have is called the serving size or unit size, which is limited by the table and chair. A person is expected to come, sit, have his food, dine, and go. For this, the ergonomically designed kind of a layout has to be made in a restaurant. So this is for increasing more people, more orders, and more money. This is where the robo has been implemented. For this kind of a situation, what happens is we are going to link on with many sensors. I'm not going to get into the sensors. Sensors can be inside the machine or outside the machine. Be whatever it is controlled by a proximity sensor. That is, when your object is coming near to certain place, then the sensor will hold on. It will connect, and then it will inform the next machine or next process. Thereby, you will have a vision system integration. That's what when you saw from Sriram, when a robotic hand is moving, or the manipulator is moving, the vision control takes care. So you go on with the minimum capability, maximizing it for the requirement of your organization. For this, you cannot, when you have a sensor, you should also have an inspector sensor. When a process is wrong, it should be stopping, and it should go on with the right process or rejecting the wrong process. So sensors of this size, this type, are required. So now when a robo comes, there are three processes of movements. One is called the translation movement. Second is the rotation and transformation. Be whatever it is. How it works is, it works on actuators. Actuators are nothing but, in fluidics, we call it as cylinders. Now, the reciprocating cylinders or rotary cylinders. Here, it's mostly of a reciprocating cylinders connected with links and joints, which is resembling the skeleton in our body. An actuator is like a muscle. So to this, we have various actuators available in the market. It can be an electric actuator with a servo stepper or a direct drive, or a hydraulic or a pneumatic, or shape memory. Shape memory is like when you have actual actions like crawling, fishing, going in a different form, which is not a straight line movement. Then you can have these kind of actuators, which is called a shape memory, or magnetorestrictive, which is called a micro-positioning one, where vibration control, taking care of your force, strain, current, and all these kind of inputs can be worked on with these actuators. Onto this actuator. The actuator can go up and come, but what is it for? It is for either positioning or giving a force. See, if it is for positioning, what it has to be done, that's the sensor control. And if it is to be controlled, then it is having a thing called free space occupation for position, or it has to touch on a rigid part, or it should not push a rigid part, or it should not push a part at all. So the amount of force, or the force control and the position control, are the more important parts in robotics, which when we have to plan for implementation. See, for all these things, in a restaurant, there are two types of activities. One, you need to clean, wash, and all these, dust prevention has to be done. So there is a difference between cleaning and scrubbing. If you want to just clean, you need not give more of a pressure or force. But when you have to scrub, your pressure should be different. This two difference has to be identified by your machine. That's where the intelligence comes. So on aspect of components, there are many things like manipulators, end effectors, actuators, sensors, controllers, processors, software for a robo. All these things are called as components. And there are many brands which are building the robos, like right from IBM, which has been the startup organization to get in right from 1970s, to Cincinnati Millicron, Westinghouse, Automatics, Olivity. All these brands are available, where each brand has its own USP, unique selling proposition, on which they design and deliver. These things are, take for a consideration of a restaurant. In a restaurant, when you go and you order the server, what he does is he takes a palm held device that's called a PDA. It's called a personalized digital assistant, where he takes like a mobile phone and he picks up your order. When he picks up your order and he sends it, it goes in the form either to go for your a la carte or your combo or your buffet. That's how a restaurant is always designed, for people to come and eat. This depends on your kitchen inventory, because if your kitchen has enough inventory, you can have different kind of offerings. Now you can have a la carte more and give better motivation for combos or for your buffet, whatever it is. But this is designed, devised by the F&B manager, the food and beverage manager, and his delegated below employees. These people can handle the control point or the input point for a robo. Then comes the data. When it comes to the data has, now people can know when you order it, how much time it will take, how much volume it has to be prepared, what price it will go. Everything is open and transparent to the customers, not only to the customers, to all the people in the value chain who are into this process of implementation of robotic restaurant. When you get in like this, what happens is the KOT. KOT is called the kitchen order ticket. Kitchen order ticket is nothing but when the palm held device input goes, it lands in 3 places. One, the kitchen. Second is in the billing area. And third is in the floor manage point. That is about people who are going to serve you. So in these 3 places, this data goes. How it is being enabled is, in the kitchen, what happens is there is a RFID sticker which is being struck on the bowl. Every bowl is designed for the order, because every order is unique. You cannot have all bowls in the same size and shapes. So each will have a different, but it goes to different tables. So the bowl has to be identified first. So it goes with the RFID sticker, and then your order gets connected to the bowl, and this bowl gets placed on a tray. The tray has the sensor. This sensor in the tray is the one which is going to talk to your table. So this tray now gets onto a navigating cart. This navigating cart is also called as a robo, which is called the serving robo. This one goes to the, after taking the bowl and tray, it goes to the chef counter. The chef counter, what does it? It has a reader, RFID reader, where when the bowl comes, it will sink in and it will tell, oh, this is the order which has been placed. Then it will tell out what is the menu, what is the quantity, and what kind of a customization. I need pepper more, I need watery, I need dry, or whatever it is. You tell the customization, all things go to the chef. Now the chef takes the order and goes on for preparation, or he orders for preparation. Once the order is done, that's the kitchen part. And once it is done, then it is dispensed on the bowl, and the bowl gets seated on the tray, and the tray now being on the navigating cart, it moves. That's where the waiting service begins. This waiting service goes to the tray, the table, and then when it syncs, the table and the tray, start to go on with the service part. Here, the sensor communicates and delivers. After you eat, you can press a button in your table so that the free robo will come and pick your utensils, whatever you have used. Now, showing on. See, this is the first robo which came into place in the world, which is called as Coney. Coney was a Watson-enabled IBM pilot. But when it came, it was more of an entertainment piece. It was not of a reality. It had only the data, and people wanted to know about the data, like it was helping out in the reception part, or it can tell you the menu. It can tell you about the combos offered. It can tell you about the discounts. It can motivate you to get more interactive. It's all through the natural language, what they had as artificial intelligence and the machine language, which was deliverable through the robo, which was the main hit of the Hilton Hotel in McLean. But later, what happened was, robos started moving into the dining spaces. That's where this robo is a serving robo, where you have the robo. It's like a machine where it picks up your order, it comes to a respective table, and it will stop there, and it will mime so that you can pick your, whatever order you have done, and then it will go back. Once the weight goes less, it goes back. See, but these things were all not enticing. People wanted to have more reality, or a kind of a novelty with which they can cherish their dreams. This is where it comes. A humanoid or a human-faced robots. The customer reception starts with a humanoid robo, where these robots are available with a tablet. So you can get to know what is available in the restaurant, and you get seated. You can, when the time is available for your table to be cleared, it'll come to your assistants. All these informations are supplied by this customer relationship reception robot. Next, see, it is also creating excitement. When you see something non-alive but still moving around, you get excited. And see, you see even youngsters taking selfie with the robo, right? And then these robots wait to take the order. And when they take the order, see, on the orders to be given, that's a PDA. You have your personalized digital assistant, on which you type what kind of order you want. That goes to the in a robo, and the robo gets integrated with the data and the order that needs to be served or to be transferred to the chef. And then they move into the kitchen. As they move into the kitchen, each one integrates through a Wi-Fi contact. And they collect the KOT, whatever order they have given, they collect that. And then they come down for a customer service. They go and deliver to the respective thing. And they also do collect the utensils after you finish eating. But this is not only the charm of a robo. Robos are now used for disinfecting, because after COVID, every space requires to be cleaned and kept nice, habitable for people to be healthy. So robos are now available for disinfecting, and robos are available for laundry services like cleaning, and they take care of your linen and they give it back to the laundry, and then they collect it back and they come out as a room service. They do cleaning of your washrooms, toilets, and all those floors. They carpet are cleaned by vacuumizers, robos. A lot of things, food and beverages are being served through the robos. You drop your orders, whatever you get in the F&B, into the robo. The robo will keep moving on the aisle, and it will go near the real room where the order has been placed, and then it will buzz out, and then it will shout hello or whatever it is, and then you have the F&B transported. And then you have a lot of robos which go on for guiding people as you enter or you want to leave, where you have your luggage to be carried, or where you have to, which room you have to be booked. I mean, you're booked into. So you keep your luggage on the robo, and the robo will guide you to whichever place it requires. And similarly, it drops you back to your car where your luggage needs to be picked up. Like this, there's a lot of things robos can do and are doing. But what? The benefit of a robo is a superior automation. It's a superior toy, frankly. It's nothing big, it's a toy. But by doing this, it is not going to remove people from the job. People need to escalate themselves to a higher position of enriched tasks. That's where, but these roundabout clock, clock operations can be handled by robos. And they do a kind of with a rigor and a precision. And this also creates a novelty and cutting edge, where human beings can do much superior tasks and leave out some which are monotonous to the machine. Human dependencies are required. See, even if it's a robo, it has to be pre-programmed, and it doesn't have a feeling. So you need to have areas where people feelings are to be managed. And servicing the gadgets, a robo cannot repair by itself, though this can also come. But servicing is through the human beings, because they know the real part of where the requirement of attachment is required. Then on the robotic things, these things all our friends have already covered. It's on the arm movement, mobility, actuation, robotic motions and all. So I'm just skipping on this and getting on to the final part, where kitchen or a restaurant is a highly susceptible source of contamination. You go to any house, even in our households, the most dirtiest place is going to be our kitchen, because we are going to have food and oil all around, because it can be in all forms, all phases of dirt. It can be a solid, it can be a liquid, it can be in a gaseous state. So as this is a sticky form, this gets dispensed onto stacks while we handle, or while we recycle, or we throw off our garbage. Wherever we do, our dirt keeps falling around. So these emulsified or airborne dirts are also available in hoods, chimneys, tables, everywhere. For this, doing this kind of a support work, we can have robots for sweeping, mopping, scrubbing, deep cleaning, dishwashing, steam cleaning, all these stuff. And finally, why people are not, though it's a craze towards robo, why people are not getting into it? Because technology gets outdated every second. When you are investing your money for now, you are not sure this is going to stay for another period of time. You cannot gauge it. That is one of the disruptions why robots are not getting implemented everywhere. Because once you invest so much of money, and within a few months, there'll be some other robo with some other features and novelty getting into market, which may collapse your business. So this is where it is user-defined kind of a project. And this automation depends on the occupational groups. If as an occupation, if you want to adopt, and this has to be a digital kind of implementation you want, then you can go with this disruption. And every learning from one point is going to be for a future. See, this forecast is always dependent on a supply chain or a wage price or a innovation or an opportunity to alleviate a human process. But at some time, when there is a lot of unemployment, people will not like robo, because that will bring a psychological discomfort. And at that time, when you talk about a robo, even their disappearance, gaze, or whatever thing, speech, posture, or whatever a robo resembles, will become a point of kind of a lighter vein. It will not be taken in a serious way thing, and they'll they'll drop it out. Coming on to the last part, where robots cannot enter. To have a clean area with a human touch, robots cannot enter unless you program it for a machine for that. And the second point is, wherever reception is having, people are best representatives rather than a robot. You can have a robot, but they can be only second to a human being. And at places where you have to support people, there you need to have people. And then you have fun centers. It is better to have people around and to have things protected, clock room, etc. You have people, because certain things machine will go rigid with its kind of an input. So there you need to help people out, move around. And then on the maintenance behind these machineries or IoT enabled machines, etc., you need intelligent people to be around, even though machines are the good form of a robots. Finally, going to impact the future restaurants is robo, and we have to be sure enough how much we can learn from it and how much to give it to it. Thank you very much.
Thank you, sir. Thank you so much. Could we have any? There is one request. Please go back to slide before this one, sir. I'm not sure.
Slide.
From Sherry. Yeah, she is not specified the slide. I think the third slide from last was what she requested.
I'll do it.
Yeah.
Third slide from last. Third slide from last. Okay, this is the last. This is the early one, and this is this one. Yeah.
Sir, you're not on presentation mode, actually. We're not able to see.
I'm sorry.
No problem.
Now, can you see? This is the third from last. What does she want?
Okay, go back to the one after that, please.
After that or before
measure, that's the one with measures, or the one after this?
Oh. After this is this.
Yeah, so the one before this. Go back to the one before this. Okay, thank you.
So you want to take a snapshot of it?
Yes, thanks.
Anyhow, this is not the way to question. we'll share you the video. No issues. Right?
Okay.
Thank you very much. Any questions? Yeah. I'll handle, or otherwise leave it to Priya to close it.
We have a request for the link. It has already been shared.
Yeah.
The link is already shared. Yeah. If there are any questions, please.
We'll go about Priya now.
Okay. On behalf of the World Resource webinar, I would like to thank all the speakers today for taking their time and sharing their insights on this topic of robotics. And to all the participants joining us from the different parts of the world, despite the time zone difference, thank you all. And as Umachandran sir rightly said, it's only the interest mutually, the workshop becomes successful. I think we've had a very good set of questions today and it has been addressed. And still, if you feel there is something further, you could write to the email ID that has already been shared. And we look forward for having more participation like this. And it really encourages us for the future days. Thank you so much.
Thank you very much. Thank you.
Yeah. Thank you, sir.
Thank you.
Yeah, so we can close.
Yeah.